Hey guys, tonight we explore the quiet wonders of boring science for sleep, the gentle steam of morning coffee in mason jars. You cradle a wide-mouthed glass jar in your palms, feeling its sun-warmed surface before pouring in freshly brewed coffee. Steam rises in lazy spirals, whispering against the rim, and you probably won't resist another batch. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And hey, while you're sipping, post your location and local time below so we can share this moment together. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin by selecting a classic pint-sized mason jar, 8 fluid ounces in the U. System. Though metric minds might call it 237 milliliters. The glass feels pleasantly cool against your palm as you lift it to the countertop. Mainstream science tells us that glass has a specific heat capacity around 0.84 joules per gram per Kelvin, which means it absorbs and holds warmth in a way that feels softer than a metal mug or ceramic cup. That's why your jar seems to hug the steam so tenderly instead of scorching your fingertips. You tilt the jar slightly and watch dark coffee pour in, the liquid surface rippling before settling into a calming stillness. As you lean closer, the first waves of steam curl upward, disappearing into the air like silent dancers. In Victorian parlors, fringe steam enthusiasts once believed these wisps carried the echoes of past conversations, so-called steam ghosts, that whispered secrets only attentive listeners could hear. You grin at the thought of ghostly gossip riding your morning brew. Chemists still debate whether microscopic glass impurities influence the pattern of those curling tendrils, but to you, each swirl feels like its own meditative choreography. You cradle the jar against your chest, feeling warmth radiate through the curved walls. That warmth triggers thermoreceptors in your skin, releasing a gentle dopamine pulse that eases pre-caffeine grogginess. It's funny how something as simple as holding a warm vessel can coax your mind into alertness, even before your first sip. Between sips, you may notice yourself tapping the jar's base against the counter to break or actually encourage the rising steam patterns. This seemingly playful gesture is an unconscious experiment in fluid dynamics. Tapping changes the jar's vibrations, nudging droplets to form and fall, altering steam density just enough for you to see fleeting miniature clouds. Your breath mingles with the escaping vapor, carrying little aromatic bits straight to your olfactory sensors. Aromatics like furfuryl mercaptan leap off the surface in tiny airborne packets, and your nose snags those compounds so efficiently that you taste the coffee before it even cools in your mouth. It's a mainstream fact that humans can detect some odor molecules at concentrations as low as parts per trillion, nature's remarkable sensitivity at work. Yet there's a quirky rumor that some baristas add distilled water with a whisper of almond extract to coax even more pronounced steam scents. Whether that's coffee wizardry or a marketing gimmick, you decide it's an experiment best saved for a weekend playtime. As the sun's early rays dance across your countertop, you notice how the mason jar's straight sides give steam room to rise vertically. If you'd used a flared or tapered mug, the steam would billow outward, losing its intimate swirl. That jar shape influence feels like a design secret whispered by industrial-era homesteaders who mass-produced these jars for canning fruits. You can't help picturing them lining basement shelves, each jar sealing summer's harvest and the gentle promise of tomorrow's breakfast. Over years, they never imagined one day their relics would cradle your morning espresso beans. Between sips, you reflect on how this simple ritual stitches together countless dawns. Every time you lift that jar, you rejoin a centuries-long continuum of warm jar moments, from pickling cucumbers to chilling preserves where heat, container, and liquid dance in quiet harmony. It's a mainstream bit of history. Mason jars were patented in 1858 and became staples in North American kitchens, democratizing safe food storage with screw-thread lids. Yet you prefer the modern twist, trading blackberry jam for coffee, repurposing heritage glass to cradle your daily pick-me-up. You lean back and watch as the steam thins, each plume growing more delicate until it dissolves in the morning air. That fading is governed by evaporation rate factors, temperature differential, airflow, and ambient humidity all playing a part. Chemists still debate whether ambient pressure fluctuations in enclosed kitchens subtly alter that rate. But to you, it's enough to simply observe and savor the dance of heat becoming vapor, the aroma rising, the glass glowing in dawn's soft glow. The first sip finally brushes your lips warm, slightly sweet, and perfectly balanced. A tiny cloud forms above the surface and drifts upward, echoing the ritual's opening flourish. You taste notes of caramel and almond, warmed by heat transfer secrets that moved energy from liquid to glass, then to your skin. It feels like a gentle awakening, not a jolt, as if your senses have been stroked awake by the interplay of steam, warmth, and scent. With that, your dawn's mason jar ritual begins. And though you'll soon move on to the day's tasks, this moment of quiet steam and gentle warmth will linger in your mind like a soft echo, urging you to pause and appreciate the simple science swirling in every breath. You lift the mason jar again and press your fingertips against the smooth glass, marveling at how heat migrates from the coffee into the jar walls, then disperses into the surrounding air. Conduction is the name of this intimate energy handoff. Hot liquid molecules collide with cooler glass molecules, passing along kinetic energy in microscopic relay races. It's a mainstream fact that glass conducts heat at about 1.05 watts per meter Kelvin, far lower than metals but higher than air, which clocks in around 0.024 watts per meter Kelvin. That means your jar warms slowly enough to feel soothing, yet efficiently enough to cradle your coffee's lingering warmth without needing a bulky handle. As you cradle the jar, you become part of the convection cycle. Warm glass heats the air in contact with it, creating a gentle upward draft that carries heat away and draws in cooler air from below. You might not see the invisible currents, but you feel the slight breeze grazing your wrist, an almost ticklish reminder of the unseen physics at play. Fringe enthusiasts sometimes hang tiny colored ribbons around their jars, claiming they can visualize convection patterns by watching ribbon flutter. Whether that's a harmless craft experiment or a quirky pastime, you can't help but smile at the idea of a ribbon-draped mason jar dancing in your kitchen breeze. Radiation also contributes, though in a subtler way. Every object above absolute zero emits infrared radiation. Your coffee and jar are no exception. That soft glow is imperceptible to your eyes, but detectable by thermal cameras, which fringe heat artists sometimes use to capture swirling rainbow patterns around everyday items. They call these thermovision artworks, believing that you can witness the soul of heat itself. Chemists still debate whether such visualizations can teach us anything new about thermal gradients, or if they're just pretty colored pictures with no deeper scientific merit. You take another sip, tasting the smooth warmth that traveled from liquid to glass to your lips. Heat transfer through conduction not only warms the jar, but also preheats your mouth, creating a more uniform taste sensation. Mainstream researchers have measured that pre-warming cups at around 40 degrees 104 degrees enhances perceived sweetness in beverages by up to 10%. A small but measurable sensory boost. It's fascinating how a simple container choice can subtly modulate flavor reception before conscious awareness even kicks in. Holding the jar upright, you rotate it slightly, observing how different parts of the glass feel warmer or cooler. That's a consequence of uneven thickness. Some mason jars have subtly varied glass thicknesses, relics of older manufacturing methods. Those slight variations create temperature hotspots and cold patches. In some coffee circles, a fringe ritual has emerged: the thermal treasure hunt, where enthusiasts run a gloved finger over the jar to find the coolest spot. A challenge, they say, that sharpens your tactile awareness. You wonder if you could win such a contest, though it feels more like playful meditation than a true scientific pursuit. You set the jar down on a coaster, causing a brief shift in temperature distribution as the bottom cools more rapidly, then warms again as heat flows back from the liquid. That process is an example of transient heat conduction, where temperatures change over time until a steady state is reached. Mainstream engineering texts often model this with Fourier's law, solving partial differential equations to predict temperature versus time curves. The math can be intense, but in your kitchen, you only care about the gentle ebb and flow, the houseplant-like patience it encourages in you. Remember the steam ghosts from earlier? A few fringe aficionados believe heat conduction through glass creates acoustic emissions. Tiny glass sings that can be heard with specialized microphones when coffee is poured. They call it thermal acoustics, claiming you can record the subtle creaks and pops of glass molecules shifting under heat stress. Whether these whispers hold any real information beyond novelty, chemists still debate whether the effect is robust enough to measure distinctly or merely a curiosity lost in kitchen clatter. You wrap both hands around the jar now, feeling warmth bloom up your fingers and across your palms. That sensation triggers thermoreceptors that send signals to your brain, releasing endorphins and lowering cortisol levels, a mainstream fact supported by studies showing that warm contact objects reduce stress in as little as 30 seconds. It's a tiny act of self-care. You engage in impromptu heat therapy with every coffee ritual, whether you realize it or not. Between sips, you reflect on how heat transfer secrets infuse this simple moment with layers of science and sensation. Conduction, convection, and radiation converge in that unassuming jar, creating a multisensory symphony: the gentle hum of rising warmth, the soft breeze of convective currents, and the intangible glow of infrared emission. You secure the lid loosely now, curious if trapping steam will change the heat flow, but also aware that doing so might mute the aroma release you cherish. As you drift toward the next part of your morning, you carry with you a newfound appreciation for the unseen choreography of thermal energy. Each sip isn't just flavor, it's physics, biology, and a dash of whimsical fringe lore inviting you to savor both taste and temperature. You press your cheek close to the mason jar, mesmerized by the rhythmic dance of condensation forming along its inner walls. Tiny beads of water coalesce in a delicate ballet, each one magnifying the coffee's dark hues for a fleeting moment before gravity pulls it downward. It's a mainstream fact that condensation occurs when water vapor cools below its dew point, around 45 to 55 degrees, 113, 131 degrees F, for coffee steam in a typical kitchen, causing gaseous molecules to transition into liquid form. That cooling happens almost instantly where steam meets the glass, creating those glistening droplets you can't help but watch. In Victorian steam salons, fringe enthusiasts once clapped their hands around teacups, convinced their warmth altered condensation patterns into ephemeral flower shapes, what they dubbed vapor blossoms. They'd sketch these ghostly blooms on paper, believing each pattern revealed their emotional state. Chemists still debate whether intentional hand movements truly affect droplet formation, or if human perception weaves these fanciful designs from random noise. You trace a finger along the jar's outer surface, careful not to break the seal of warm air inside. Each sliding touch collects a few scattered droplets on your fingertip before flicking them back into the jar with a tiny pop. You smile at this playful experiment, noticing that larger droplets form at surface imperfections, microscopic pits or etchings left from the glass-blowing process. Mainstream studies show that droplets prefer to nucleate at these defect sites, where lower surface energy makes it easier for water molecules to stick together. Between sips, you tilt the jar and watch gravity coax droplets to join into rivulets that stream downward, occasionally leaving behind branching trails reminiscent of miniature rivers. That rivulet formation is governed by capillary action and surface tension, two principles at the heart of fluid mechanics. Fringe tinkerers attach fine pen nibs to vessels, channeling drips into predetermined pathways as condensation art, though whether these creations hold any scientific merit or are just artful waterworks, scientists still debate. Your breath fogs the outer glass for an instant, adding a new layer of moisture that dissipates in a gentle blur, like a soft focus lens adjusting itself. That momentary fog is similar to the phenomenon you see on a cold window pane during winter warm. Humid breath condenses on the cooler surface, only to evaporate seconds later. Psychologists note that these transient images can trigger childhood nostalgia. Remember that first car ride home in winter, pressing your forehead to the frosted glass as the jar cools. You notice the rate of droplet formation slows. Ambient humidity and air temperature shift the balance on a humid morning. Condensation clings stubbornly, while in drier conditions, droplets vanish almost as quickly as they appear. Mainstream meteorology confirms that relative humidity above 60% will yield slower evaporation rates, making the jar's walls swim with moisture longer. You recall a fringe claim that artists use humidity-controlled chambers to craft the perfect condensation canvas, but chemists still debate whether such precision yields truly reproducible patterns. You press your lips to the rim and inhale steam scented with rich coffee oils. As that warmth circulates, you hear a faint dripping as droplets fall back into the liquid, and you momentarily wonder if those micro-drips alter the coffee's salinity or strength. In truth, the volume is negligible, but it's a playful question to attribute to steam alchemists who historically believed condensation recycling could intensify flavor. Whether that holds any real taste advantage, culinary scientists still debate. Cradling the jar again, you note how condensation reveals the hidden topography of your mason jar ridges where glass seams were joined, tiny scratches from everyday wear, and the slight curvature at the base edge. Each imperfection hosts its own microcosm of droplets, a miniature world of liquid physics playing out in slow motion. It's humbling to realize how much complexity hides within that simple glass sphere. Between each slow pull of coffee, You contemplate how condensation droplets catch sunlight in prismatic flashes, sometimes refracting tiny rainbows for a split second. It's a charming fringe anecdote that some early photographers used mason jars of hot coffee as impromptu kaleidoscopes, capturing fleeting spectra before the droplets vanished. Photographers still debate the usefulness of such amateur techniques, but you're content knowing that art and science have long flirted around your morning brew. You settle back, feeling a sense of calm wash over you with the rhythmic drip and silent droplet dance. It's a reminder that even in everyday objects, simple physical laws create stories worth watching. As you finish this sip, you know the next chapter of steam's journey awaits. Each condensation bead a tiny testament to nature's quiet artistry. You bring the mason jar to your nose and inhale deeply, letting the tapestry of aroma molecules envelop your senses. Those volatile compounds like guaiacol, responsible for that smoky note, and 2-furfurylethiol, the powerful coffee character responsible for that fresh-baked bread scent, swiftly vaporize from the hot liquid and sail upward in invisible currents. It's a mainstream fact that over 800 distinct aroma molecules have been identified in coffee, each with its own temperature threshold for vaporization. Some waft off at as low as 40 degrees Celsius 104 degrees, while others need closer to 90 degrees Celsius 94 degrees to truly sing. You could almost swear you smell hints of caramel, toasted nuts, and even a whisper of floral jasmine dancing together in the steam. Between that rich bouquet, you notice how your nostrils flare and your eyes close just a bit, as if the world around you gently fades to let you savor each inhalation. Fringe coffee sommeliers sometimes attach tiny nasal cannulas to mason jars, claiming they can channel concentrated aroma streams directly to the olfactory epithelium for an ultra-nose experience. You chuckle at the image of someone wearing a snorkel-like device just to smell their morning brew, but you admit it's tempting when the coffee scent is that mesmerizing. Chemists still debate whether isolating aromas in this way enhances perception or if it just feels fancier without real benefit. You pause to consider the role of jar temperature on aroma release. When the glass cools below the coffee's temperature, it actually draws fewer volatile compounds away, trapping more steam and more aroma inside. That's why some baristas preheat mugs to keep those precious molecules dancing free. Mainstream research shows that keeping coffee above 60 degrees Celsius maintains maximal aroma release for about 5 minutes before significant losses occur. It's a delicate balance: too hot, and the aroma becomes overpowering; too cool, and it dwindles to a whisper. Your fingertips brush the jar's rim as you lift it for a sip, and you notice how the wide mouth shapes the aroma's breadth. A narrower opening would concentrate scents, funneling them straight to your nose, but at the cost of comfort, you might scald your nostrils. A fringe gadget called the aroma funnel combines a glass narwhal horn with a mug, supposedly focusing the aromatic plume. You wonder if you'd look ridiculous sipping through a clear glass horn, but then again, who are you to judge someone chasing the ultimate sniff? Chemistry enthusiasts still debate whether funnel shapes truly concentrate volatile compounds or simply scatter hotter air differently. As you inhale again, you realize humans can detect some aroma molecules at concentrations as low as parts per trillion, a mainstream marvel of our olfactory prowess. You might not identify every chemical by name, but you instinctively recognize the harmony of fruity esters, roasty pyrazines, and nutty lactones that define your brew. It's like your nose is a finely tuned instrument, always ready for a morning concerto. You tilt the jar slightly, aiming the opening toward your face, and let the full cloud of scent envelop you. That immersive inhale triggers your limbic system, stirring memories of childhood kitchens, warming loaves of bread, or of lazy Sunday breakfasts. Scientists have found that olfactory stimuli link directly to memory centers in the brain, making coffee aromas powerful mood setters. In one playful fringe experiment, researchers paired coffee scents with ambient forest sounds, claiming participants felt transported to a woodland cafe. Whether that cross-sensory trickery truly deepens relaxation or just adds novelty, neuroscientists still debate. Between sips, you dab your wrist at your pulse point and gently rub your forearm, old perfumers' techniques for grounding strong scents so they don't overwhelm. That's a quirky tip you picked up warming a drop of coffee oil on your skin before brewing can prime your nose to catch even subtler notes. It sounds extravagant for a morning habit, but you admit it adds a playful ritual. You're not just drinking coffee, you're staging a tiny sensory performance. As the steam wafts upward, you note how the light catches flecks of oily essence on the surface, each shimmering droplet glimmering like liquid amber. Those coffee oils, triglycerides carrying flavor compounds, also influence aroma release. Mainstream food scientists observe that emulsified oils can hold on to some volatiles, releasing them gradually rather than all at once, smoothing out the olfactory experience. It's like a slow-release capsule for fragrance, ensuring no note leaps out too sharply. You catch yourself smiling at the simple magic of it all: glass, liquid, heat, and scent collaborating to deliver an intimate morning ritual. Fringe alchemists sometimes carry sealed vials of concentrated coffee aroma to sniff between sips, claiming it resets the palate. It seems a bit over the top, like bringing a perfume bottle to breakfast, but you can't deny the allure of capturing that first whiff and bottling it forever. Coffee scientists still debate whether such aroma boosters truly reset your nose or simply fool you into thinking you smell more than you do. Your final sip leaves a faint, warm breeze of scent drifting away from the jar. You watch the plume curl and fade, carrying the last of those aromatic compounds off into the kitchen air. It's a serene moment, the conversation between volatile molecules, and your nose slows to a hush, like two old friends saying goodbye until tomorrow's dawn. Then, with a soft clink, you place the jar back on the countertop, feeling oddly pampered by this slow dance of aroma, heat, and memory. You cradle the mason jar again, this time turning it slowly in your hands to appreciate its clean lines and generous opening. The jar's shape isn't just for show, it's a deliberate design that influences how steam and aroma escape. Mainstream fluid dynamics tells us that containers with a larger cross-sectional area at the top allow for broader, more diffuse steam plumes, while narrower openings create concentrated, faster-rising jets. Your wide-mouthed jar thus acts like a chimney with a cathedral's vaulted ceiling. The steam has room to billow and swirl gently before breaking free, creating that graceful, lazy drift you love. As you tilt the jar ever so slightly, you watch the steam cling to the rim before escaping in soft eddies that spiral outward. That phenomenon stems from the Venturi effect. When steam moves through a constricted opening, its velocity increases and pressure drops, drawing in surrounding air. In your case, the wide mouth means minimal constriction, so the steam rises more slowly, encouraging subtle interactions with ambient air currents. You might call it slow-motion steam ballet, where every pirouette is visible long enough for your sleepy eyes to follow. Fringe steam sculptors sometimes experiment with fluted or hexagonal mason jars, claiming that the angular sides create complex aroma vortices, tiny swirling patterns they call aromograms that heighten sensory pleasure. They'll hold up different jar shapes in front of high-speed cameras to capture elaborate steam mandalas, then frame them as artisanal art. Whether these patterns truly enhance flavor perception, culinary pros still debate, but you secretly admire their dedication to steam aesthetics. You lift the jar to your lips and notice how the wide opening bathes your nose in a gentle plume rather than directing a narrow beam of steam like a metal thermos might. That softer release feels more relaxing, no sudden gusts scorching your face, just a gradual caress of warmth and scent. Mainstream ergonomics research shows that container shape can affect user comfort. People exposed to broad steam plumes report 25% fewer microburn events than those using narrow-necked mugs. That statistic might not win you any barista awards, but it does explain why mason jars have become a go-to for at-home caffeine rituals. Between sips, you press your palm flat against the jar's side and imagine how the tall, straight walls guide upward steam currents without much lateral diffusion. Contrast that with a rounded teacup, where steam hugs the curve and escapes unpredictably, sometimes smacking your cheek or drifting off too quickly. In your jar, every swirl stays in sight, giving you a captive show of fluid motion. It's akin to comparing a slow river in a canal to a wild mountain stream, both water, but entirely different experiences. You set the jar down and peer through its clear walls at the rising mist. A fringe community of steam cartographers has even tried etching tiny ridges or fins inside glass vessels to orchestrate predetermined condensation paths. They claim these micro-grooves can guide droplets into ornamental patterns, turning each jar into a living sculpture. Scientists still debate whether such modifications have any practical benefit beyond novelty, but the persistence of these experiments is a testament to human curiosity, even if it's aimed at redesigning coffee containers. As you wrap your fingers around the jar, you note how the straight sides provide 4 uniform contact points, distributing heat evenly across your palm. A curved teacup or contoured mug, by contrast, would concentrate warmth in fewer zones, potentially creating hotspots. Mainstream thermal imaging studies confirm that straight-walled vessels yield more uniform surface temperatures, enhancing user comfort and reducing risk of accidental burns. It's not a groundbreaking revelation, but it does underscore the thoughtful simplicity behind your trusty jar. You lift the jar for another sip and observe how the large opening frames your view of dark coffee depths. That visual cue primes your brain for flavor. Psychologists call it visual taste expectation, where seeing a generous liquid surface area signals richness and fullness. Your jar shape thus not only choreographs steam, but also shapes perception and interplay of sight, smell, and taste that feels almost psychological. Fringe neurogastronomists still debate how much container shape directly influences perceived flavor versus actual olfactory inputs. But in your morning ritual, the effect feels undeniably real. Between sips, you fiddle with the jar's lid ring, which you've left loosely threaded in case you want to trap steam briefly. The tiny metal ring, when snugged slightly, forms a partial seal that causes the steam to pool and condense more on the walls before escaping. You notice condensation drips magnify the swirling patterns you saw earlier, then release in slow droplets that plop back into the coffee. It's a playful mini-cycle shape influencing steam retention, retention influencing condensation, condensation influencing drip behavior. You grin at how a kitchen hack can turn your routine into a tiny scientific demonstration. As the jar empties, the steam plume thins, but its shape remains true, a wide, gentle fountain gradually tapering as it rises. You reach back for the jar, still marveling at how such a simple geometric form governs so many dynamic processes. From fluid velocity to aroma dispersion, from heat comfort to visual prominence, your mason jar isn't just a vessel, it's a curator of sensory experiences. And though some may dismiss its shape as a relic of food preservation, you know the true secret functional design can feel magical when you pause to notice. You finish your last sip, watching as the final vapor ribbons slip away. Tomorrow, you might experiment with a narrower jar or even a vintage soda bottle to compare shapes, because exploration is part of the fun. For now, though, you tuck this wide-mouth wonder away with gratitude, carrying forward a deeper appreciation for the shape that shapes your steam and your mornings. You lift the jar and peer into its depths, noticing how the coffee surface has receded ever so slightly since your first pour. That gentle disappearance is evaporation in action. Liquid molecules at the surface gain enough energy to break free into the air. Mainstream science tells us that evaporation rate depends on three key factors: temperature, surface area, and humidity. With your jar still warm at around 70 degrees, evaporation hums along smoothly. The wide mouth gives plenty of surface area, and the kitchen's moderate humidity around 50% means the steam rises uninterrupted. As you cradle the jar, you feel the faint draft of vapor leaving the rim. In arid climates, fringe steam surfers sometimes use petroleum gel rings on jar rims to trap moisture longer, claiming they can ride condensed droplets like miniature waves. They argue this gel creates a micro-humid microclimate that slows evaporation dramatically. Whether that trick actually tames the rate of steam loss or simply makes for stickier hands, chemists still debate the gel's true efficacy versus placebo. You swirl the coffee gently, noting how the curved meniscus shifts across the jar's inner wall. That shifting surface area subtly alters evaporation. More tilt equals more exposed liquid, hence faster mass loss. Mainstream food scientists measure that a mere 15-degree tilt can increase evaporation rate by up to 8%. A tidbit often applied in flavor concentration processes, think thickened sauces or reduced stocks. In your morning brew, that swirl becomes a mindful way to stretch those lingering aromatic moments just a tad longer. Between sips, you lift the lid ring and let the jar breathe more freely. That slight venting increases the airflow over the liquid surface, driving evaporation faster. It's a mainstream fact that forced airflow, like a gentle breeze from a fan, can increase evaporation rates by as much as 30%. You recall setting a desk fan to low speed beside your workspace, watching steam streams whip into slender threads as the coffee cooled more quickly. It was a clever hack for those who need their caffeine wake-up, but hate the wait for lukewarm disappointment. You lean back and dubiously consider fringe lore. Some baristas swear by ultrasonic humidifiers placed near brew stations to create a layer of saturated air, supposedly slowing evaporation and keeping aroma in check. The idea is that a high local humidity gradient traps coffee steam near the cup, enriching each inhale. Culinary researchers still debate whether this elaborate setup yields any real sensory benefit, or if it's simply a gimmick to impress customers with steamy coffee clouds. Feeling experimental, you dust the jar's rim with a few grains of sugar, another fringe trick you once read about. The sugar crystals attract water, creating tiny nucleation highways that drag condensed droplets back into the steam plume, ostensibly extending the visible swirl. It's a playful gesture, and you can't tell if it genuinely influences evaporation or just gives your eyes a few extra seconds of dancing mists. Scientists still debate whether hygroscopic additives like sugar reliably alter evaporation dynamics, but you enjoy the micro-experiment nevertheless. As you sip again, you reflect on how ambient humidity can make or break your ritual. On muggy mornings, the air's moisture clings to every droplet, slowing evaporation so much that steam hangs thick and heavy. Conversely, on dry days, you get a fleeting wisp of vapor that vanishes within seconds, a disappointment for any steam enthusiast. Mainstream meteorology confirms that relative humidity above 70% can halve evaporation rates at identical temperatures, a fact that's crucial for industrial drying processes but equally impactful in your kitchen sanctuary. You tilt the jar further now, creating a larger surface area and kicking evaporation into overdrive. The coffee's visible shrinkage feels oddly intimate, like watching time slip through your fingers in slow motion. A fringe collective known as the Drop Watchers hosts live streams where they chart jar evaporation over hours, annotating each percentage point loss with poetic reflections. They invite viewers to meditate on impermanence as the liquid level falls. Whether that taps into genuine mindfulness or is just a quirky live stream theme, thinkers still debate the line between science and spectacle. You pause and breathe in, noting that as evaporation carries water into the air, it leaves behind a stronger concentration of solutes, coffee oils, acids, and sugars at the surface. That concentration effect subtly intensifies flavor and aroma over time, a mainstream principle used in sous vide reductions and flavor-infused syrups. In your jar, those lingering notes become richer with every minute, a slow crescendo of taste that aligns perfectly with your unhurried pace. Between sips, you wipe a stray droplet from the outer wall and watch the steam plume thin to near invisibility. Heat transfer to the air has dropped. Without enough thermal energy, evaporation slows to a near halt. You remember reading that at room temperature around 25 degrees, evaporation of a coffee surface this size would take upwards of 8 hours to fully disappear. That makes your remaining steam feel like a precious reserve, one you're determined to savor until it whisper fades away. Chemists still debate whether adding surfactants, a common industrial evaporation retarder, could find a practical home in a kitchen setting, but you're content to stick with sugar and fan tricks. Finally, you sip the last warm drop, feeling how the concentrated brew carries a slightly bolder taste, proof that evaporation has selectively whisked away lighter water molecules first. You place the jar down, letting the final wisps of steam drift upward in thin, fading trails. This evaporation rate dance, you realize, is more than just a physical process. It's a metaphor for how small changes accumulate over time, shaping your sensory experience minute by minute. You lean forward, gazing at the mason jar as if it were a tiny cloud chamber, watching steam plumes reveal hidden currents in the air. In a classic physics demonstration, a cloud chamber uses supersaturated vapor to show particle tracks, but here, your coffee-steamed air forms a makeshift mini-chamber where heated moisture traces fluid motion. It's a mainstream fact that cloud chambers rely on temperature gradients to condense vapor along ionized paths, mapping out unseen particles. Though your jar lacks radioactive sources, the principle of visible vapor trails remains the same. Warmer, humid air meets cooler surroundings, and becomes momentarily visible. Fringe hobbyists have dubbed such setups DIY cloud scopes, placing mason jars atop cold metal plates to accentuate steam trails. They believe that swirling patterns can indicate subtle air currents in the kitchen drafts from open windows or fan influences that are otherwise imperceptible. Whether these home experiments yield accurate airflow maps or simply create pretty visuals, fluid dynamicists still debate their scientific rigor. Some argue that uncontrolled temperature and humidity make any pattern reading more art than reliable data. You draw the jar close and watch as ribbons of steam spiral downward near the edges, hinting at gentle downdrafts caused by cooler air sinking along the glass surface. Meanwhile, the central plume rises in a steady column. This combination of updraft and downdraft forms a convection cell, a foundational concept in meteorology and engineering. Mainstream studies use smoke or tracer gases to visualize such cells in wind tunnels, but your coffee steam does the job perfectly for a momentary glimpse of nature's cycle. Between sips, you tilt the jar to one side, making the steam hug the inner wall before slipping out in a sideways stream. This lateral flow demonstrates inertia and boundary layer effects. Steam close to the glass moves slower due to friction, while the core moves faster. Fringe steam artists sometimes paint jar interiors with fluorescent dyes, then illuminate them under blacklight to capture boundary layers in vibrant color. They claim these art meets science projects help students grasp fluid mechanics more intuitively. Educational researchers still debate whether such visually stunning demos aid learning or simply distract with aesthetic flair. As you sip, your warmed breath mingles with the rising steam, forming a transient fog around the jar's mouth. That fusion of streams, a personal convection dance, creates a unique mixing zone where coffee vapors blend with exhaled air. It's a mainstream fact that mixing different vapor sources can alter scent perception, sometimes dulling or enhancing particular notes. In fragrance science, perfumers experiment with sniff blending to understand how compound interactions shape the final aroma profile. You set the jar down briefly and move a small potted succulent into its airflow path. The plant's delicate fronds quiver as the steam breeze brushes against them. It's a playful nod to wind tunnel testing, where scale models measure aerodynamic forces. Though your succulent isn't logging data, its leaves provide a visual cue for airflow direction and speed. Fringe gardeners sometimes use this trick to ensure even mist coverage in greenhouses, monitoring how humidity-laden air circulates among plants. Agricultural scientists still debate whether intermittent steam misting benefits houseplants more than constant humidifiers. Picking the jar up again, you press your ear close to the glass wall, half listening for the faint hiss of escaping steam. That sound arises from tiny pressure differences as vapor escapes through the minimal gap under the lid ring. Mainstream acoustics research shows that steam jets can produce measurable frequencies, used in industrial diagnostics to detect leaks in steam systems. Engineers listen for telltale high-frequency squeals to pinpoint faulty valves before catastrophic failures. In your kitchen, the hiss is far too gentle to trigger alarms, but it's comforting in its own quiet way. Between sips, you notice how ambient lighting refracts through the steam, creating subtle halos of backlit mist around the jar. Photographers sometimes call this the steam aureole effect, capturing ethereal images that blur the line between microscopic droplets and ghostly apparitions. Whether these photos convey any new scientific insight or simply evoke mood, optics experts still debate the value of artistic science photography versus controlled laboratory imaging. You cradle the jar and imagine mapping these visible currents with chalk-dusted air, tracing lines where steam leaves its mark. In wind engineering, smoke visualization is a common tool, and your coffee steam is the paleo smoke of breakfast rituals. Fringe DIYers have even rigged tiny LED grids around jars to track steam movement with light sensors, translating patterns into digital maps. Whether these makeshift instruments can rival professional particle image velocimetry (PIV) systems, fluid mechanics researchers still debate their precision. As the jar empties, the visible steam currents fade, leaving only the faintest tendrils clinging to the rim. That disappearance marks the end of your mini cloud chamber experiment. You take a final sip, letting the last echoes of steam drift upward. This simple, impromptu fluid dynamics show reminds you that every morning brings an unscripted science demo right in your hands. You cradle your nearly empty mason jar and let your mind wander to alternative vessels. What if this ritual played out in a ceramic mug or stainless steel tumbler instead? The material of your drinking vessel shapes the experience in more ways than you realize. Mainstream science tells us that different materials have distinct thermal conductivities. Glass sits around 1.05 Wb. Ceramic pottery ranges between 0.6 and 1.5 Wm depending on composition, and stainless steel jumps up to about 16 Wm. That means a steel tumbler feels hotter faster, sometimes too hot to touch, while a ceramic mug warms gradually, like a slow sunrise in your hand. You imagine holding a heavy ceramic mug. Its thicker walls might insulate your liquid longer, keeping coffee at a toastier 140 to 60 degrees for several extra minutes before tumbling down to lukewarm. In fact, mainstream temperature logging studies show that a 12-ounce ceramic mug can maintain drinking temperature 15 to 20% longer than the same volume in a thin-walled glass. That extra thermal cradle changes more than just warmth. It subtly shifts aroma release and flavor perception, nudging sweetness or bitterness in different directions. Fringe vessel alchemists believe the microporosity of unglazed pottery can absorb trace oils and flavor compounds over time, seasoning the mug like a cast iron skillet. They'll save a favorite coffee mug exclusively for espresso, claiming repeated brews create a flavor-enhancing patina that smooths acidity. Whether this seasoning truly layers nuanced flavors or simply traps old oils, culinary scientists still debate whether surface porosity yields measurable taste benefits or just lingering rancid notes if not cleaned properly. You chuckle at the thought of carrying 24 seasoned mugs to your desk, one for light roasts, another for dark roasts, maybe even one reserved for decaf. It feels like joining a secret society of coffee vessel connoisseurs. Chefs will sometimes use unglazed crocks for fermenting pickles because the porous walls let tiny amounts of air escape. Fringe brewers have tried fermenting coffee in earthenware to coax wild yeast flavors. Chemists still debate whether such pottery fermentations add anything beyond rustic novelty, or if you're simply overcomplicating caffeine delivery. Switching gears, you envision a sleek stainless steel tumbler. That chameleon of the coffee world offers durability and rapid heat transfer, but at the cost of subtle taste shifts. Mainstream bench tests reveal that metal vessels can impart faint metallic notes, especially if coffee sits too long, because trace metal ions leach into the liquid at hot temperatures. Most people won't spot this, but your taste buds, honed by years of slow sips, might detect a whisper of cold brew tang even in morning espresso. Between sips, You recall reading about fringe ion infusion enthusiasts who deliberately swirl acidic coffee in copper-lined mugs, claiming that minute copper dissolution enhances mouthfeel and sweet perception akin to adding a pinch of salt to savory dishes. They herald ancient Indian kulhads, unglazed clay cups, and Nordic ale jugs as proof that metal or clay interactions are culinary gold. Whether these ion dances truly orchestrate flavor symphonies, food chemists still debate the ethics and safety of drinking acidic liquids from reactive metals. You lift your jar to examine the embossed logo, pondering surface chemistry's role in flavor. Glass is famously inert, chemically stable, and non-porous, so it won't leach or absorb anything. That's why laboratory beakers and test tubes are almost always glass. Mainstream lab safety guidelines favor borosilicate glass for high-temperature work because it resists thermal shock and chemical attack. But here in your kitchen, that inertness means pure, unaltered coffee, every flavor molecule presented straight, unfiltered by container interactions. Fringe glass whisperers claim that different glass blends soda lime versus borosilicate have detectable taste signatures. They insist they can tell whether a jar is lab-grade or grocery-grade just by swirling coffee and smelling trace alkali vapors. According to them, a thin thread of lead-cadmium oxide in fancy-colored glass adds a silkiness to flavor release. Scientists still debate whether these trace elements, often regulated to safe limits, can meaningfully shift sensory profiles, or if experienced tasters are simply indulging in placebo. You set the jar down with a gentle clink, feeling its familiar rigidity. That contrast in mouthfeel versus a smooth ceramic rim or cool steel lip influences perception, too. Psychologists studying oral somatic perception observe that the hardness and texture of a drinking edge can modulate flavor. Intensity harder rims are linked to sharper taste experiences, while softer, rounded rims can soften perceived bitterness. So your jar is relatively thin. Hard edge might be delivering a slightly brisk coffee kick compared to a pillowy ceramic lip. Between sips, you tap gently on the lip, noting how solid the glass feels. Fringe sensory experimenters sometimes tape tiny foam rings around cup rims to test rim compliance effects. Does a cushioned edge mellow your brew? They film tasters' face reactions to sips from rigid versus padded rims. Flavor scientists still debate if these tactile cues only matter in lab conditions or if they meaningfully affect everyday coffee enjoyment. You lift the jar once more and swirl the remaining coffee, watching the liquid cling to the sides in teardrop rivulets, a behavior called the coffee ring effect, reminiscent of wine legs in a glass. That effect depends on surface tension and viscosity interacting with container surface energy. Different materials change those interactions. Glass supports clean, consistent rings, while ceramic's micro-roughness can produce patchy trails. Mainstream enology and barista guilds study these trails to estimate alcohol or sugar content. You apply the same curiosity to caffeine, imagining yourself a coffee sommelier reading fluid tears. As the final droplet falls back into the brew, you reflect on how container choice weaves through every sensory layer of your ritual thermal comfort. Aroma release, taste perception, tactile feedback, and visual cues. The mason jar's simplicity, its inert glass, straight sides, and standard rim offers a reliably transparent canvas for science's daily performance. Yet, you appreciate how experimenting with ceramic or metal vessels could reveal subtle nuances you never noticed before. You take one last sip from the glass rim, cool now, tinged with a hint of lingering heat, and decide that tomorrow you'll test a ceramic cup. You'll note the temperature curve, aroma intensity, and flavor notes, and maybe even draft a vessel compatibility chart on your next live stream. After all, exploring the boundary between material science and sensory art feels as satisfying as that first breath of steam, a gentle reminder that even the humblest jar can open gateways to curiosity. You lift the mason jar once more, feeling the familiar warmth against your palms as you settle into a comfortable nook. Now, consider how warmth, scent, and texture intertwine in a sensory symphony, a synergy that transforms simple coffee into a soothing ritual. Mainstream neuroscience tells us that multisensory integration occurs in the orbitofrontal cortex, where signals from touch, smell, and temperature converge to create unified flavor perceptions. In other words, your brain doesn't process heat, aroma, and surface feel separately. It weaves them into one seamless taste memory tapestry. As you cradle the jar, the smooth glass offers a tactile consistency no handle to grab, just a continuous warmth that your fingertips track like a gentle pulse. That texture primes your thermoreceptors and mechanoreceptors simultaneously, amplifying the comforting effect. In studies, participants who held warm cups rated their coffee as richer and more satisfying than those holding cold mugs, an example of haptic influence on gustatory experience. It's a mainstream fact that tactile cues can alter perceived sweetness by up to 15%, revealing how powerful touch truly is in flavor perception. Between sips, you close your eyes and inhale deeply, letting the aroma cloud fill every recess of your nostrils. Those volatile molecules, esters, phenols, aldehydes cascade into your olfactory bulb, delivering sensory data that merges with the jar's thermal feedback. You feel a gentle release of serotonin as warm contact and rich scent combine, soothing pre-dawn jitters and sharpening mental clarity. It's a subtle interplay. Heat opens nasal passages, scent molecules penetrate more freely, and texture binds it all together into a comforting whole. Fringe scent architects have experimented with tactile aroma grids, textured surfaces etched on mug exteriors that are said to modulate steam release patterns for enhanced sniffability. They argue that micro-grooves guide vapor plumes into more concentrated streams, boosting aroma intensity without raising temperature. You imagine these grooves as invisible channels directing fragrant whispers to your nose. Whether those micro-textures truly shape scent clouds or simply look futuristic, sensory scientists still debate their efficacy versus traditional smooth-walled designs. You run a fingertip along the jar's rim, noting how its thin, hard edge contrasts with the yielding sweep of your lips. That mouthfeel cue where hard meets soft influences flavor sharpness. Psychologists describe this as oral somatosensory modulation, where rim compliance affects bitterness perception. Softer edges often temper harsh notes, while rigid rims accentuate them. Your jar's unyielding glass lip may be nudging you toward a brisk, lively coffee sensation, an intentional design by heritage canners, now unwittingly steering your taste buds. Between sips, you shift position so the jar rests on your forearm, letting its warmth travel inward. That prolonged contact raises skin temperature by a few degrees, which research shows can intensify aroma detection by increasing receptor sensitivity. It's a mainstream finding that skin warming, even small rises to around 34 to 35 degrees, 93-95 degrees, can boost olfactory acuity by nearly 20%, making every inhalation feel more vivid. You appreciate how such a simple gesture deepens your sensory plunge into the coffee's character. As you draw the jar toward you for another sip, you notice how the gentle steam swirl tickles your whiskers, creating a soft facial massage. That tactile thermal brush against stubble or skin can trigger pleasant chill responses akin to ASMR. Fringe ASMR baristas have leveraged this, filming close-ups of steam-kissed beards for viral steam beard massage videos, claiming it induces instant relaxation. While neuroscientists still debate whether such brushes elicit true ASMR responses or just novelty tingles, you can't deny the mild shiver of contentment it brings. You pause mid-sip to reflect on how texture extends inside too. The fluid's viscosity and mouth-coating behavior work in tandem with warmth. Thicker microfoam layers or oil-rich crema stick to your tongue, prolonging taste perception as heat melts those layers away. Mainstream food chemists measure coffee's viscosity in centipoise, noting that higher values correlate with perceived body and sweetness. In your jar, that tactile coating lingers just long enough to blend with the warmth radiating from the glass, two tactile cues dancing across your palate. Between sips, you recall a quirky fringe trick some sensory mixologists add: a pinch of fine silk powder, edible, odorless microfibers that dissolve instantly to smooth out liquid texture and trap aromatic compounds longer. They swear it creates a velvet mouthfeel and enhanced nose-to-cup contact. Whether that's more couture than culinary, flavor technologists still debate the safety and sensory payoff of such exotic additives versus straightforward emulsifiers. You decide to stick with plain coffee, but you admire the creativity behind such experiments. You inhale one final aromatic cloud, noting how the gentle steam caresses your nostrils. Warm glass cradles your hands, and silky liquid coats your tongue all at once. This sensory synergy where warmth, scent, texture, and taste converge creates a moment that transcends mere caffeine delivery. It's a holistic ritual that engages every sense in unison, crafting a microcosm of comfort and focus before the day unfolds. As the jar empties, each sensory channel quiets in turn. The steam plume thins, scents fade, and heat gently dissipates from the glass. You sit back, letting the convergence of senses echo in memory, carrying you into the final chapter of your morning journey. You cradle the nearly empty mason jar and reflect on the morning ritual's broader context, a gentle woke-up routine that blends science, mindfulness, and habit into a seamless experience. Each element you explored: heat transfer, condensation, aroma release, container shape, evaporation dynamics, fluid visualization, material science, and sensory synergy has woven together to create a comforting microjourney. Mainstream behavioral researchers note that such rituals, performed consistently, can reinforce neural pathways associated with positive emotions and focus, making habits both calming and habit-forming. In this extended routine, you've engaged in intentional observation, watching steam curls, tracing droplets, inhaling aromatic clouds, and mapping airflow. Fringe mindfulness coaches sometimes call this thermodynamic meditation, urging practitioners to use thermal sensations as anchors for attention. Whether or not this fancy label holds scientific weight, mindfulness researchers still debate the role of sensory anchors versus breath focus. The practice clearly grounds you in the present moment. As the final wisps of steam drift away, you take one last slow sip, tasting the concentrated essence born from minutes of evaporation and solute enrichment. That flavor crescendo underscores a simple fact: slowing down magnifies subtleties you'd otherwise miss. Mainstream gastronomy advocates a slow taste philosophy, recommending gently paced eating or drinking to heighten flavor enjoyment. You've embodied that philosophy in liquid form, sipping coffee as though it were a fine tea ceremony. You press your palm against the jar's side one final time, feeling residual warmth. That contact reminds you of the hundreds of generations who held similar vessels, though for pickling fruits, rather than sipping lattes, each interaction forging quiet connections across time. Fringe cultural historians argue that everyday objects carry tactile memories, suggesting that material culture links us to the past in subtle ways. Anthropologists still debate whether such tactile nostalgia influences behavior meaningfully or simply romanticizes vintage artifacts. But you feel a soft echo of tradition in your palms. Between breaths, you notice the soft background hum of the fan you turned on earlier, merging with the residual hiss of steam. That ambient white noise, combined with the jar's warmth and aroma, forms a gentle soundscape and unscripted ASMR track for your senses. Mainstream studies confirm that low-level ambient sounds, like fans or soft chatter, can enhance relaxation and focus, making your ritual not just a taste experience but a multi-sensory retreat. You set the jar back on the counter, empty, yet filled with the morning's collected insights. Its clear walls seem to glow in dawn's light, as if content to share its secrets before slipping into stillness. In fringe circles, some ritual minimalists advocate ending such routines with a silent moment of gratitude directed at the vessel itself, acknowledging its service in crafting mindful pauses. Whether gratitude to objects has measurable effects, psychologists still debate the causal power of gratitude practices. It fits your mood perfectly. You rise from your nook, carrying the comfort of your ritual forward into the day. The steam show is over, but its lessons linger. Notice heat, follow condensation, savor scent, respect shape, observe evaporation, glimpse fluid flows, question materials, and honor sensory synergy. These steps form a science-backed pathway to calm, one that you can revisit whenever mornings feel rushed or chaotic. Your final act is simple: glance back at the empty jar, offer a small nod of acknowledgement, and step away full of warmth, clarity, and quiet curiosity. This little ceremony, played out morning after morning, reminds you that the everyday harbors endless wonders when you pause to look. Slow now your thoughts as the day begins to unfurl. Let the sharp clarity of each steam tendril soften into a gentle haze of memory. You have witnessed how heat moves and aroma drifts, how glass shapes and senses meld, and now, in the hush that follows, allow each detail to fade to a dreamlike whisper. Feel your breath coincide with the soft, receding pulse of warmth against your skin, as the last echoes of hiss and steam dissolve into the morning light. Rest in the quiet residue of this ritual, where science meets serenity and curiosity eases into contentment. You've traced droplets and inhaled fragrance, charted currents and tasted concentration. Yet these acts need not linger beyond gratitude. Let them drift away like the final wisp of steam, leaving behind only the gentle hum that carries you forward. In this lingering quiet, may you find the same calm curiosity waiting whenever you return, an open invitation to rediscover the small wonders in every cup. Each morning holds a new brew and a fresh dance of molecules. When the world accelerates, remember this slow ceremony and let it guide you back to stillness, Now, gently stretch your shoulders. Inhale one last mindful breath, and step into your day with warmth in your palms and softness in your mind. Sweet dreams, or rather, sweet beginnings until tonight's next steam-lit journey, when you and your mason jar meet again in calm discovery.